Hey, third grade, it's Miss Fifield. I'm here today to walk you through week 4, day 1 of your new packet that you should have picked up last week. Okay, these new packets have a lot more work each day because we're moving into more new learning, where before we were just doing a lot of reviewing of things we'd already been working on in class. Some of this is still going to be familiar. We have done some of this, but each day we'll start to do more new work. Okay, so hopefully you already have your packet out and you're looking at week 4, day 1, just like you see on my screen. As always, we start with our fluency. Today's fluency is a little bit tougher. It's not just practicing multiplication and division anymore. This one is asking us to use the digits 0 through 9 and fill in the blanks to make the answer closer to 200 than to 300. So before we can do that, we see we have 400 something minus 100 something. These boxes are where we're going to fill in numbers from those digits, 0 to 9. So we can pick any digits we want. I reset this up down here because we've talked about so many times how we cannot subtract horizontally. We have to stack vertically so that we can unbundle and regroup. You also will see I have a number line right here. I have 0, 100, 200, 300, 400. And we're going to use this first to figure out what digits we should put here. We want our answer to be closer to 200 than to 300. So that means we're going to want to start pretty close to the 400. It's going to be a little greater than 400 because it's at least 400, right, with the 4 in the hundreds place. So we can see we could start close to 400, and it's quite a ways on the number line, right? It's much more than 100. If we only subtracted 100, we would land in the 300 area, but we want it to be over here closer to 200. So we're going to need to subtract 100 and then a lot of tens and a lot of ones. So we want a low amount of tens and ones here, but a high amount for our 100 number so that we can get very close. I know that the halfway point between 2 and 300 is 250. I'm going to want this number I subtract to be very big so I can get on the far side of 250, closer to 200. So I'm going to get my marker and I'm going to just try. I can always erase, right? I'm going to try, let's see, I'm going to do 401 because that's as close as I can get to 400, right? And I need to subtract, I said, a really big number. So we can, again, use these digits all the way up to 9. So I'm going to use the biggest digits I can think of. I'm going to put a 9 here, and the next biggest digit is 8. So I'm going to put that here. And then I'm going to subtract. I'll use a different color marker to do my work. And if I need to, I can always go back and erase and try again if it doesn't work. I cannot subtract 8 from 1. I cannot unbundle any 10s. I don't have 10s. I'm coming to my hundreds place, taking 100 away. I have 300 here, and I unbundle that. I now have 10 tens. That's great so that I can subtract in my tens. I still need ones though. So I'm going to take 1 of those tens, which will leave me now with 9 tens. Unbundle that 10 in the ones place, and I have 11. 11 minus 8 is 3. 9 minus 9 is 0. And 3 minus 1 is 2. So my answer, my difference, answer when I subtract, is 203. I wanted it to be closer to 200 than 100. 203 would be way over here on my number line. So that works great. As long as my number here is less than 250, this is correct, as long as it's between 200 and 250. So that means using smaller digits in these places and larger ones here. You could use 1 and 0, 1 and 2 here, 9 and 8, 8 and 7, bigger numbers down here and smaller numbers up here will help you land somewhere along here. You do not have to use the same numbers as me to get the correct answer. There's lots of ways to get your answer correct as long as your answer difference is between 200 and 250, you're correct. If not, try again. All right, new learning. This is really not new learning. This is what we were working on when we switched to working at home. So this might feel new, but it's not brand new. Imagine the rectangle is a piece of paper. We draw a line through the middle. We have 2 equal parts, 1/2, 1/2. If we split each half of the rectangle above, this strip will have 4 equal parts. 1/4, 1/4, 1/4, and 1/4. Think about a beaker, a tool used in science labs. So that's this glass or plastic cup that holds water and has lots of marks on it to help us measure. A beaker is full when the liquid reaches the fill line shown near the top. So right here, it's all the way up to there, it's full. How do we estimate the amount of water in a beaker that is 1/4? So this little thought bubble is going to tell us what we need to do. That says, first, I need to partition my whole into 4 equal parts. Remember, partition means to draw those lines and kind of break it into different parts from the whole. I can estimate to draw a tick mark halfway between. So here's a tick mark, these little lines they call tick marks. It's halfway between the bottom and the top, and then each one of these is in half and in half from the original half. After that, I need to shade one of the equal parts. So this bottom 1/4 here shows the same as 1/4 up here. It's just represented in a different way. Now we're going to try it together. So we have draw lines to match the fraction strips with the correct unit fraction. One has been done for you. So they took this example here, which shows the unit fraction would be 1/2, a line there. Up here I see 1, 2, 3. These are thirds. The unit fraction is 1/3. C, 1, 2, 3, 4, 4 equal parts. The unit fraction is 1/4. And 6, 1, 2, 3, 4, 5, 6, yep, 1/6. So you should have drawn lines just like that. Okay. Estimate the amount of water in the beaker by shading the drawings as indicated. The first one is done for you. 1/3. The beaker is split into 3 equal parts with 1 shaded. Okay, they did that one for us. This next one, we need to show 1/2. 1/2 is 2 equal parts. If we need 2 equal parts, we need 1 line. Remember, however many parts we need 1 less line to decompose or partition into those equal parts. So 2 parts, 1 line, and then you shade it in. I can't do a very good job on here with this marker. Oops. But I'm sure you're doing a great job on your packet. Okay, so shade in 1/2. The next beaker, we want to show 1/5. 5 parts means 4 lines. So estimate to make them, we want them to all be the same size. So I'm going to go 1 line, 2 lines. If you mess up, you can always go back and fix it. 3 lines, 4 lines. Pretty close to the same size. Not perfect, but that's all right. And then I'm going to shade this 5th here at the bottom. In this case, you would always want the bottom part to be shaded because in a beaker, when you pour the water in, it falls to the bottom. So you would start at the bottom and work your way up since it's representing liquid in a cup. All right, did you split the beaker into 2 parts for 1/2? Yes. Did you split the beaker into 5 equal parts for 1/5? Yes, hopefully. If you followed along with me, you definitely did that. Okay. Our problem set now. A beaker is considered full when the liquid reaches the fill line shown near the top. So it's this little line here in each. That's full. That'd be one hole. Estimate the amount of water in the beaker by shading the drawing as indicated. The first one is done for you. So this would be 1 whole, 1/2. They shaded. You need to do 1/4. So earlier when we showed 1/4, we did first partitioned into half and then each half in half. Because in order to make 4 equal parts, we need 3 lines. And we show 1, 2, 3. Just made the little tick lines over here. I'm only going to make this first one go all the way across because that's the one I'm going to shade. Shade it as best I can here with my little computer marker. All right, so yours should look something like that. The last beaker, we need to show 1/3. 3 equal parts means 2 lines. So I'm going to estimate about here and here. And then I'm going to take my bottom third all the way across because I want to shade this whole third at the bottom. And shade it in the best I can. Oops. So yours will look better than mine. It should look something like that. Okay? Number 2 in your problem set. In the space below, draw a small rectangle. I already drew mine because you've seen me use the marker. So I used an actual rectangle, so I don't have to draw it. Estimate to split it into 2 equal parts. How many lines did you draw to make 2 equal parts? What is the name of each fractional unit? So there's really 3 things we need to do here. The first thing we need to do is estimate and split it into 2 equal parts. 2 parts, 1 line. So first we show it. They're also asking how many lines did you need? Needed 1 line. I'm gonna write that on my board and you're gonna write it on your paper. What is the name of each fractional unit? 2 parts, each is called 1/2. So I'm gonna write that fractional unit in unit form, just like that, okay? B, draw another small rectangle, did that. Estimate to split it into 3 equal parts. How many lines did you draw to make 3 equal parts? What is the name of each fractional unit? So this time we want 3 equal parts, which means 2 lines. So once you've drawn your rectangle, we'll draw 2 lines here and here. And then over here, I'm going to write 2 lines. If you are using complete sentences, that is awesome. I am not going to because we would be here for a very long time with my computer marker. All right, we drew 2 lines. What is the name of each unit? And there are 3 parts. They are called thirds. So 1 fractional unit is called 1/3. Write it just like this. 1/3. Okay, number 2 is done. The last one we are going to do today. A plumber has 12 feet of pipe. He cuts it into pieces that are each 3 feet in length. What fraction of the pipe would represent 1 piece? Draw a fraction strip to help you. So I have my fraction strip drawn. You should be drawing one on your paper. And the whole thing is 12 feet. So I'm gonna use a bracket. Remember, drawing like this shows me this whole thing represents 12 feet. You can abbreviate feet, FT. He cuts it into pieces that are 3 feet in length. So I'm not going to partition into 12 parts because he's not doing each foot, he's doing chunks of 3 feet. So what I am going to do instead is I'm going to skip count by 3. 3, 6, 9, 12. So when I skip count by 3, I see how many parts I'm going to have here. That would be one chunk. Another chunk would give us 6 feet. A third chunk would give us 9 feet. And a fourth chunk would give us 12 feet. 1, 2, 3, 4 equal parts. In order to make 4 equal parts, I need to draw 3 lines, one in the middle, and then splitting each of those in half here, like this. So this shows me 3, 6, 9, and the whole thing represents the 12 feet. What fraction of the pipe would one piece represent? So if I'm talking about just one piece, I'm going to shade one piece so I can better visualize and see what I'm talking about here. So here's one part, one of 4 parts. That is 1/4. We write it like this, or in unit form, 1/4. Like this. So 1 fraction equals, I'm going to label up the top, 3 feet. Just like that. That is the end of your week 4, day 1 work for today. So we hope you're staying safe, staying healthy, and continuing to work hard. If you need help on this or anything else, you can always reach out to your teachers. You also can look back at the fraction review video, which is posted on our YouTube page as well. I posted that video about 2 weeks ago, so that can help you if you need to refer back to some basics about fractions, because it has been a long time since we've been together. And if you need it, it's there. So use every resource you have on the YouTube page, and continue to reach out if you need help. And we'll see you soon. All right.